Assalamualaikum. Hi guys. So we are going to focus how to balance redox equation in this video. For your information, redox reaction can occur in two conditions. The first one is acidic and the second one is basic. Let's follow the steps systematically so that you can balance the equation in an easier way. I will introduce to you acronyms RAO CHAIR. We are going to start with R first, redox, where you have to determine the couples based on their similarity of elements sharing, and then divide them into two half equations based on two processes, oxidation and reduction. Next one, you have to balance atom other than oxygen and hydrogen. Next, you have to balance oxygen by adding water, H2O, followed by hydrogen by adding proton, H+. Next step, you have to balance charge by adding electron at the side which has higher overall charge. So this is where you have to add up electrons at more positive side based on their total charge. And last but not least, you have to determine for both half equation, you got the same number of electrons so that you can cancel out them. So this is RAO CHAIR, the acronyms that I'm going to use when balancing redox equation using ion-electron method. I'm going to introduce to you two methods here. So in this part, we will continue with method 1, how to balance redox equation in acidic solution. You can see that I have this equation. So first thing first, please choose two couples. Two couples here, I've already explained in the previous video, where you have to determine which one at the reactant side and product side that share the same element. So based on this example, you can determine this is one couple and this is another one couple, because this one share element ferrum and this one share element manganese. Next step, you have to divide the equation into two half reactions. The first one is oxidation and the other is reduction. So I'm going to pick the couple which is easier to determine the oxidation number. So I'm going to pick ferrum. For Fe2+, the oxidation number is positive 2. And for Fe3+, the oxidation number is positive 3. So you can see that there is increase of oxidation number. So Fe2+ undergoes oxidation to produce Fe3+. So I will put O as oxidation and R as reduction based on my two half equations. So automatically another couple for MnO4- to produce Mn2+ will be reduction. So choose one only, the most easier for you to determine the oxidation number. So this is for the first acronym R. Next we go to the second acronym, balancing the atom A other than oxygen and hydrogen for each half equation. So you have for oxidation, one ferrum and one ferrum, both sides. You don't have to take a look at the charge yet at this part. So take a look at the number of atoms. So next we go to reduction, one manganese and one manganese. Just ignore oxygen here. Next we go to step 3. You have to balance oxygen atom by adding H2O. So for oxidation, you just skip because there is no oxygen in oxidation part. But for reduction, you have 4 oxygen atoms here. So I'm going to add up 4 H2O at the right side. So now it's balanced. 4 oxygen atoms and 4 oxygen atoms. Settle for step O. Now we continue for hydrogen. How to balance hydrogen? You have to add H+. So for oxidation, you just skip it because there is no hydrogen to add up. For reduction, you have MnO4-. You have here 4 H2O. So it means that 4 times 2 equals to 8 hydrogen atoms here at the right side. So you are going to balance by adding 8H+ at the left side. Settle for step 4. Next one, we are going to balance the charge where you have to add electrons to the more positive side. We are going to do this one by one because this part is very crucial. Let's go with oxidation first. For oxidation, you have this equation where Fe2 plus, the charge will be positive 2. For Fe3 plus, the charge is positive 3. So how many electrons you should add? You are going to add up at the positive side, which is positive 3. So at the right side is the position for your electron. But how many of them we are going to determine in mathematical way. So I have here 3. What I have here is the charge 3, and then the charge of electron is negative, so I'm going to put minus x to determine how many electrons should I add up, equals to 2. 2 here is for the opposite side. So I rearrange to find out my x value is 1. So how many electrons should I add up at the right side? 1. So I'm going to put plus 1 electron. Very simple. Let's go to reduction. So it's a bit longer for this part, but we have to do it one by one. So I got MnO4 minus, the charge is negative 1. And then for 8H plus, you have to bring 8 here times with the charge of hydrogen, positive 1. And adding up all of them, you will have positive 7 as your total charge at the left side. Now we go for the right side. You have positive 2 for Mn2 plus and 0 for the neutral compound such as water here. So adding up all of the charges, you will have positive 2 for the total charge at the right side. So how you want to determine for this part, we are going to add electron at the more positive side. So 7 is more positive compared to 2. So my electron should be at the left side. So I'm going to determine in mathematical way. I have 7 here minus how many electrons I want to determine equals to 2 because at the right side you have 2. So rearrange your x, you will have number of x is 5. So how many electrons at the left side of reduction? It must be 5 electrons. Very simple. Now we are going to continue for the next step where you have to cancel the number of electron lost with the number of electron gain, and the value of them should be same. So let's see here. For oxidation you have 1 electron, but for reduction you have 5 electron. So the value is not the same one. So you have to do something for the oxidation where I'm going to multiply all of them by 5. So you will get the same number of electrons for oxidation and reduction. Due to the position of electron is in opposite side, so I'm going to continue with the next step where you can cancelling the species appearing on both sides. So you can see that these opposite electrons with the same value, you can cancel them out. And then the final step, we are going to combine all species at the right side and all species at the left side together. And it will be one whole equation that is balanced. So you will have this final equation. How am I going to check whether my equation is correct or wrong? Because quite a lot of steps here, you follow the RAO chair. But do I got the correct balance equation? I'm going to calculate the total charge for both sides. So you can see that for reactants, you have positive 17, and for the products, you have positive 17 as well. So this is how you always need to double check your answer. So from here, you got the balance equation. This is very easy if you follow the acronyms RAO chair step by step and apply what you've learned so far. So I'm going to leave it to you here. We are going to continue in the next video. Bye!